dear students. Today we'll discuss the oscillation of a body dropped into the tunnel dug the diameter of the earth. In the previous class we have discussed the oscillation of a body in the U-tube shaped liquid it is, and a floating body, right? So these all things we have already discussed in the previous class. So both are experiencing the simple harmonic motion. That means they are exhibiting the simple harmonically at the equilibrium position when they are executing the its own up and down, or the floating part of moving up thrust and down thrust. So in simple pendulum also we have discussed, seconds pendulum we have discussed. So all are experiencing the simple harmonic motion. Means simply they are executing the restoring force which is responsible to show the which is executing the simple harmonic motion. So now we'll move on towards the oscillation of a body dropped into the tunnel dug of the diameter of the earth. Here means we have considered the earth whose radius is r here, and at the radius is r, having the earth surface, and at the exactly center portion we have dug the tunnel here along the diameter of the earth. Means this is the diameter of the earth here. You can take a horizontal, you can take this is the vertical diameter, right, along the diameter of the earth here. If you place the small body whose mass is m into the tunnel, let you consider the point P at any point on the tunnel here, and once you just dropped into the tunnel here, the depth of the body at this instant below the earth surface is d here. So depth of the earth surface, these things we have already discussed in the last chapter, that is gravitation. So depth, what is there here on the surface, what is the gravitation, on the depth it is what is the gravitation, and the above the surface what is the gravitation. Now we are allowing the body to enter into the tunnel that is already it is dug in the depth of the earth, right? So we are allowing the mass of the body just dropped into the tunnel here. So that point may comes here as soon as you drop it here, point anywhere in that tunnel. So that is just below the surface of the earth. It is that part we have called it as it is a depth, right? So this instant below the earth surface is a d here, and the distance of a body from the earth surface is y. Means once it is dropped here, it will go under the the distance from the center portion of the earth surface. So this distance is that is of y here. So depressed means dropped means from the equilibrium position it is coming certain distance below the surface. So that distance is called as here y, right? Now let g and gd be the acceleration due to gravity at the earth's surface and the depth respectively. That we know here acceleration due to gravity on the earth surface, we'll call it as it is a g, right? So this is g is the acceleration due to gravity on earth's surface. It is if any body is there on the surface of the earth. So as we all are able to stand on the surface of the earth, means it is due to the acceleration due to gravity. It is gd is what? Acceleration of due to at the depth of the earth surface. Depth of the earth surface, just below the surface it is. So we are making the body of a mass m is entering or allowed in the tunnel. Tunnel is there inside the, means we have arranged in such a manner that it is going along the diameter of the earth here. So as we know here, right, so acceleration due to gravity at the depth below the earth's surface is, the GD is given as G of 1 minus D by RTS. So this formula already we know in the previous chapter only, right? Once we have the depth here, I'll just go for the complete expression formula. I'll write it to the above here. So we have GD is equal to, that means acceleration due to gravity just below the earth's surface, G in bracket D minus R here. D means what it is? Depth, right? So if you go ahead with the expression form here, R minus D by R it is, where R minus D, this part, complete radius minus dropped part will give you Y here. So R minus D will give you Y, the distance from the center portion of the earth to the body where it is there, after just allowed to be in the inside the tunnel there. So we are getting G of Y by R here, G of Y by R. So GD, the acceleration due to gravity, will get you GD is equal to G Y by R. So look at here, body is moving downward but force is applying upward direction. It is coming back to upward direction. That means it's trying to come towards its mean position. So force and displacement are opposite, that's why a negative sign comes here. Force and displacement are in a negative direction, it is, that's why it is coming negative sign here. So force acting on the body is what here? Force acting on the body. So which is force acting on the body, so which is showing the simple harmonic motion, that is of F is equal to mass into GD. So we have no force F is equal to mass into acceleration, but body is there here under the downward. So that's why this will place a GD here, GD. So I'm writing here GD, and the force which is acting here. So M is there, GD value is, what is that? Minus G Y by R it is, right? So minus G Y by R. Y is oppositely directed. Force and displacement are oppositely directed. The body execute the simple harmonic. Now we got the body which is experiences the force in the depth of the diameter, but the body which is experiences the simple harmonic motion. Simple harmonic motion. What is the force here? K into Y here, right? Y means Y distance we have taken here. Compare these two forces. So what you are getting? Ky is equal to minus minus cancels here. We'll get it directly. Mg R by Y here. So y it cancels here, remains with K is equal to mg by R it is. So mg by R we have got it here, but the time period executing the simple harmonic motion is how much it is, where it is particle experiences the simple harmonic motion, right? So we have a time period is equal to 2 pi by root of m by k it is, root of m by k. So k value we know here, what is that? K is equal to mg by R. So 2 pi root of m by mg R will come up. So get cancels, remains with the 2 pi root of R by G. So this is the time period required to complete the oscillation. Oscillations in the sense what it is, body is moving up and down here. If this is the time period, then frequency will be 1 by T it is, that is 1 by 2 pi root of G by R it is. So F is equal to 1 by 2 pi of root of G by R it is. So this is the frequency. Frequency means what here? The number of oscillations in, or the number of oscillations is completed in one diameter. So that is the relations is accepted. The thing is the body is also experiencing the simple harmonic motion when the body is inside the surface, or the tunnel dug along the diameter of the earth is also experiences the oscillations here. So that is very important here. Next one, we'll go ahead with these part, that is free oscillations and the forced oscillations. So what is the free oscillations and what is the forced oscillations? These are the common thing it is. We have discussed until then what is oscillatory motion, periodic motions, right? And how it will be executing simple harmonic motion. What are the functions, how it is discussed. These all things we have discussed. Free oscillations means, free oscillation is the oscillation made by the body which is not subjected to any other external force are called as the free oscillations. That means frequency at which the body performs the free oscillations means it does not depend upon any external force which is acting on the body to be execute the simple harmonic motions. Naturally it is going to be under the simple harmonic motion. Such kind of oscillation, such kind of body executing free type is it is does not depend upon any external force it is. So that kind of oscillations are free oscillations, and that frequency body which performs the oscillation is called as a natural frequency. Naturally means it is inbuilt, it is directly, it is going ahead without any disturbances or without any waiting for the external force to be acting on it to execute the simple harmonic motion. The displacement and the time graph also we have to discuss here. So before going to that, let us understand the taking the one example here, that is of simple pendulum. Also we can take a simple pendulum. We are not applying any just external force. If you go ahead with the suspension of a bob here, right, with the measured or any kind of length, it is just you pushed it here. Pushed it in the sense was it is not external force. It is a one kind of impulse. It is short force is acting on the long force is acting on a short intervals of time. Just you touch it here, it will move towards the one extreme position and it will move towards the another extreme position. This we know this is a positive. This is known as a negative extreme position it is. But once it is moving this direction, it is coming to mean position, again it is moving to extreme position of negative, and it is coming. So totally it is going to motion and fro motion, that completes the time period here. So it is doing by itself simple harmonic motion, to and fro motions by itself it is executing without waiting of external force. Force itself is acting on the particle, that makes the body to be coming back to its original position or the mean position. So such kind of oscillations are called as a free oscillations, means without any external force. Any external force it is. So without any external force. So such kind of oscillations are called as a free oscillations here, right? And its frequency, we'll call it as it is a natural frequency. So natural frequency, right? So we can take a example of simple pendulum also, and stretching the string is, and like just string is there here. You can take a spring also, string also. So wherever you can just stretch it here, it will move to the certain distance here. So later it want to come to its mean position only. So naturally it is happening. If you stretch also, it will execute the simple harmonic motion. If you just suspend also, it will experiences the simple harmonic motions. Like means if you just suspend here string, so suddenly it is moving up and down direction, up and down direction. So it is exhibiting the simple harmonic motion. So such kind of body experiences, the free oscillations are called as the free, natural frequency here. So these are the, you can take a plenty of examples also. The best example is a simple pendulum, and the another one is stretch the string in plugged at the some point and perform the free oscillations with its natural frequency. So by this we'll take a one more type of the oscillation, that is a forced oscillation. So which is that forced oscillation here? The body performs this free oscillation, it continues to be loses the energy. Before going to that forced oscillations, we'll go ahead with the displacement and the time period graph, how it is executed. So I'll keep this one diagram so that you need to understand this. So x is equal to minus, if you draw the graph displacement versus graph here. So let us take the time period t by 4, t by 2, 3t by 4 here, and this is t. So it is x is equal to 0, x is equal to a, x is equal to minus a here. Now it is moving from 0 to extreme position of plus, and again it is coming to 0 position, then again it is negative extreme position, it is right. So again it is coming to 0 position. So this path is there, no, this path is there, no, this completes the one time period, it is to and fro motion. The range is there, no, here the path is, or the distance is there, no, that is called as amplitude here. So that is of amplitude here. So once you go ahead with the natural frequency, the amplitude will be remains same here. So amplitude will be remains same in the sense what it is naturally happening. So like this, like this, like this. This is not drawn properly, I'll just explaining here. 0 to maximum, 0 to maximum. So this part will be constant, it is amplitude will be constant, it is in case of free oscillation, free oscillation it is. So amplitude will be remains constant. In case of forced oscillations, what will happen, that we have to cross check here, right? Let us go ahead with the what is the meaning of forced oscillation here. Now we have studied force oscillation. We'll compare with this free oscillation. So naturally it is happening. So naturally frequency it will be, right, x is equal to plus 2, x is equal to minus here. So it is moving in this direction, time period it is, and the graph is amplitude will be constant, it is amplitude will be constant. So displacement versus time period. So x is equal to positive, x is equal to negative here, so x is equal to 0. So best example is simple pendulum example it is. Now we'll go ahead with the forced oscillation. So when body performs the free oscillation, right, it continuously loses its energy. So it is continuously loses its energy. Why means kinetic energy at the mean position it is a maximum, potential energy at the extreme position it is 0 in the sense it is minimum. So once it is executing the simple harmonic motion continuously, energy is going to loses here. So energy is loses and reach to the extreme position, kinetic energy will becomes what it is 0. Then potential energy at the extreme position, it is maximum, right? So kinetic energy becomes loses and comes to the potential energy where it is maximum at the extreme position here. Then due to that frictional resistance of the surrounding medium, when why the energy loses by the free oscillation of a body executing here, due to the frictional force. What is that frictional force which makes the body to be opposes the force acting on it? That we have already studied in the previous class. So in which medium the particle executing the oscillation, that medium's friction will develops in such a way that body is loses its energy here. That means frictional resistance means opposition, it is either you can take a frictional, either you can take a resistance. So both they have taken it as means both the particles opposes to the flow of, flow in the sense what, execute the body to oscillation here freely. So that surrounding medium will plays the important role to loses the energy here. So amplitude of oscillations goes on, decreases, and finally the body comes to rest here. A body can be made to oscillate continuously with a constant amplitude by the application. What kind of application? It is made to of an external periodic force, it is. So if you go ahead with the amplitude and time graph here, forced oscillation, right? So when you go ahead with the graph of displacement, x is equal to a and x is equal to minus a here at the time period t. So t by 4, t by 2, 3t by 4 and total t. So beginning it will move from positive to 0 here, extreme to 0, 0 to negative extreme to again 0. So like this it is continuous, right? Like this it is continuous in case of free oscillation, it is, right? So once it is in the forced oscillation here, look at this part. So it's medium, in which medium the body is executing the simple harmonic motions by the particle here. So what will happen, amplitude is not going to be constant here. So what will happen, it will move towards the extreme position. I'll remove this to understand this time period, it will disturbs you. So this part, it will be up to certain point, amplitude will be remains same, again it will start decreasing. So again it will start decreasing. So like this, and one fine point it will reach to be stopped here. So look at here, amplitude at this portion, amplitude of this portion. So this is increases, this is decreases. That means what here, amplitude is not to be constant in this case. Why means body loses the energy here. So kinetic energy is maximum at the mean position here. Kinetic energy is maximum. As it is moving, kinetic energy decreases, and fine point, it stop oscillating at the point. So here it is oscillating, and it finds to stop here. That means amplitude is going to decrease due to what it is, due to the, in which medium, say it is in the air medium. In air medium, there are the resistance which will plays the role of a particles to stop the oscillation. That is, a frictional resistance will plays the very important role to make a body to be stop oscillating at the certain point. Beginning it will be maximum energy will be there. So when it is continuously oscillating, so it starts decreasing the amplitude due to what it is, medium, in which medium the particle executing the oscillation. So that medium develops in the sense medium itself has some resistance. In that medium, particle executing oscillations means that medium resistance will plays the very important role to stop the oscillation. So such kind of oscillations are called as a forced oscillations, means we are forcing them to execute the oscillation. So just like a tuning fork, you might have seen the tuning fork here. or else best example it is guitar you can take, or the sitar, or any musical instrument like a string is stretched. So you can I'll just draw. So many string will be stretched here, right? So in that the artist will just stretch the string. So at a certain point its amplitude will be what kind it is? It is showing maximum, 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 maximum. So in this, at the some fraction of second or the some time period, it's going to be decreases and stops here. So this is the best example. It is forced to be oscillated. It is forced to be oscillated, or else you can go ahead with the tuning fork. So it is just like a U-tube, it is shape it is. So vibration will be takes place here, 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 here. So you just hit to the rubber pad, it will move towards the certain distance, vibrate it on both the side it is. Then after that its velocity, its amplitude also, here it is maximum, minimum, maximum here, 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 and again it will comes to 0. It will stop doing the oscillating certain point. Again if you pressurize that instrument, again it will start oscillating. So to and fro motion, again up and down. So such kind of oscillations experienced by the particle, that is called as a forced oscillation here. So forced oscillation, when you go ahead with the one more graph here, where if you played with the point, amplitude and time, but in free oscillations amplitude is constant, so such kind of graph is not possible here. So amplitude as it is increases, right? So sorry, it is not time period, it is a frequency. So frequency is very important here, that is reverse point of the time period. Means as a time increases, frequency decreases. As the frequency is more, means time is less. As the time increases, frequency is less. So reverse it is, inversely proportional it is. When frequency of external force increases, that time amplitude of that particle forced oscillation is also increases. Frequency increases means amplitude also increases. See, so look at here. So frequency increases, amplitude is also increases. Frequency decreases, amplitude is also decreases. So look at here, this part is what? F naught. F naught means what? It is force for the natural frequency. Means every body has its own frequency. That is a natural frequency it is. So that part is called as a natural frequency. That's why the military persons, the march fasting during on the bridges, they will not do, due to what it is, that point will comes to the in the next just after this part only we'll discuss, that is damped oscillation. So these are the natural frequency, where frequency increases in the forced oscillation. When frequency increases on the forced oscillation here, amplitude is also increases here. And one fine, amplitude becomes maximum at the resonance frequency. Resonance in the sense what? Applied frequency with the natural frequency matches, and they are becomes equal to each other. That point we'll call it as a resonance frequency. That amplitude becomes maximum at the natural frequency, or resonance frequency F naught here. So this is about the free oscillations. Now the next comes here, the last part, it is damped oscillations. So what is that damped oscillation here? So we will write the first things we have written with a free oscillation. Second thing is a forced oscillation, right? Amplitude is not constant, it is continuous, loses energy, continuously loses energy due to the medium resistance or the friction, right? So graph you can take it here. find it is displacement and the time period, right? X is equal to a, x is equal to minus a it is. So loses energy here. This is about the forced oscillation here. This is a free oscillation. Now next comes here damped oscillation. So damped oscillation. What is this damped oscillation? When body is made to oscillate in the medium, that we know body is made to be oscillate in the medium, amplitude of oscillating body continuously decreases. In case of forced oscillation, what we have discussed, the same things it is happening. Amplitude is going to be decreases continuously with the time, and ultimately the body stops at oscillating. Such oscillations are called as a damped oscillation. So suddenly it will comes to the rest. Suddenly in the sense what? So as soon as the oscillation starts, amplitude is maximum at the beginning, right? And as it is time goes, amplitude decreases, and at fine point, body stop oscillating. So that position is called as a damped oscillation. If a motion decreases due to the frictional force and exerted by the medium on the body. So due to that, same it is, due to that friction only, that is x is equal to a to x is equal to minus a, where x is equal to 0, that is of displacement here. So as it is moving continuously, its amplitude becomes decreases and fine point it is stops here. So such kind amplitude is decreases due to the frictional force, or you can say frictional resistance in the medium. On which medium it is? Body is medium, body is oscillating. So oscillating, right? So that is called as damped oscillations. So amplitude decreases as the time increases here. So amplitude decreases as time increases. So periodic oscillations of a body decreases amplitude and called as a damped oscillation. See, I have used the word periodic oscillations, means it is continuous to be in the function. We can, and periodic means after a certain time it will comes to the same time period, but the amplitude is decreases here. So that is called as a damped oscillation. You can take a best example of tuning fork also, and the your simple pendulum also. So that is of a simple pendulum. And there are the two again types are there, that is of what we can say angular simple harmonic motion, and other angular simple harmonic motion, and its differential equations. It is also be discussed very sensitively, but it is not as compared to the whatever discussed in the topics. So keep practicing, and do prepare yourself for the competitive exams. Concept understanding is very important here, and by this it's concluded that the portion whatever it is needed for to be understand in these all classes we have discussed, right? This has to be said to be as almost completed. Discussion is completed, but the practice is not completed. It's our part is ended, your part is begins now. Keep practicing. All the best.